Hi, this is a supplementary lecture for using for regression using XLSTATS. Most of the while the lectures don't require you to have XLSTATS or Minitab, in this particular section Minitab is emphasized, and usually that's the case, but in this case we have mostly people using XLSTATS. So let's go ahead and do this in XLSTATS, and we'll see if we and we'll so that we can cover those examples more thoroughly. The example that we're going to go through is the one that's in the book on service and capacity. I think it's called Service and Capacity Part 2. We're going to quickly do a scatter plot, correlation coefficient, and then we'll do a regression. But we're going to do it, and by the way, this is the block diagram that you should have, where we've got the Y is our service level, which is a number. People hours is a number also. That's our predictor or our driver. And anyway, when we do the regression, we're going to go through and we're going to do it right. We're going to first build the model. This is going to seem silly when we only have one predictor, but it will not seem silly when we have more than one predictor. This essentially is looking at the p-values. I'll show you where to look for that. Second is we're going to check how good the regression is, how strong that regression is. By the way, it's related to how tight that scatter plot is. If the scatter plot kind of looks like this around the line, like this, the regression isn't going to be that strong. On the other hand, if the scatter plot looks super tight along a line, like, say, this, right, something like that, our R-squared is going to be very high. It's going to be very strong. So it's related to that scatter plot. So we'll show you how to check that. Third thing is we're going to check the validity of our regression. Now, whenever we build a model and we draw lines and make predictions and things like that, there are some assumptions. Our assumptions are around something called residuals, and I'll show you what those are, and I'll also show you how to do those checkings, that checking. And finally, we're going to use it for prediction. Okay? So let's go to it. We're going to do the example of service and capacity. Let me get that open. Now, you guys have this. It's called Service and Capacity Part 2. All right, so here we go. We've got it open, and I've got a bunch of things open in XLSTATS, which I'm going to close down. Pardon me. All right, that's one of the problems that we run into. I'll leave that one open. Okay, so here we go. Whoops, I opened it and then must have closed it. Service and capacity, here we go. I'm just going to select all of these. Now remember, we have to think about what our Y variable is and what our X variable is. I'm going to click to num. Yes, I know I selected 3, but I'm really only interested in column A and column C. That's 2. All right, here we go. First thing is I've got to get the scatter plot right. This is people hours versus experience, but I want service level on the y-axis, and I want people hours on the x. There we go. That's the scatter plot I want. Okay, now without doing too much adjusting, remember that when we went over it in class, our scatter plot was to first look for outliers. Looks like that might be a bit of an outlier, right? Right there. Maybe even this is a bit of an outlier. Second thing is to look for the form. Well, it looks kind of like a line. It's a bit of a blob. It is positive. It's in a plus direction. As I increase people hours, service level does tend to increase, but it's not that strong because of that blob-like appearance. Excuse me. So that's right. That's it right there. Second step on the train is to just note the correlation. Correlation goes between -1 and +1. +1 being something which is basically very tight along a line that's in the positive direction. -1 being very tight along the line in the negative direction. Here's our x, here's our y. X and y, here's our x, here's our y. And 0 being basically nothing, basically being a total blob, no line whatsoever. This one's clearly in between this one right here and the really tight one. And look at that. It does happen to be about halfway there. Not too much of a surprise. Okay. Anyway, so that's the correlation. If we want to see what's real, whether it's real, we have to run a test. And we're going to do that on the Correlation and Linear Regression tab. So please go to that. What we want to do here is we want to do a test of whether it's equal to 0, whether this correlation coefficient right here, I'm going to put that in yellow, is equal to 0 versus it's not equal to 0. In this case, it certainly does look like when we look at that p-value, p is low, which means, of course, the null must go. So it does indeed look like it is different than 0. In other words, that correlation coefficient is real. Okay, let's move on to more interesting stuff. I think, anyway, that is the line. So remember, when we're the model. Remember, when we're building models, let's take a look at what we're going to be doing. We're going to build them the right way. Building them the right way means we first look for the p-values, then we check the strength, then we validate our assumptions by looking at the residuals, then and only then do we use it for prediction. So let's go ahead and do those steps, all 4 of them. First things first, let's validate by looking at the p-values. Build our model. In this case, like I said, it's going to be trivial, and that involves looking at the slope. Is the slope equal to 0 or not equal to 0? That's a hypothesis test. In this case, it turns out the p-value is less than 0.05, so we're going to go with it. Yes, it's not a coincidence that these two numbers are the same. The correlation coefficient p-value and the slope p-value are the same. Okay. That just means that we need to keep it in the model. What we were really testing, not that. What we were really testing was, is this a good model for the data where B1, oops, I've messed this up. B1 is 1.054 and B0 is 62. Is this a good model for the data, or should we just essentially cross this out and just use the average? Okay? What this says is, no, we shouldn't just use the average. We should go ahead and use this coefficient that we got. It's significant. That's all it says. Not too interesting at the moment. All right. Second stop on the train is to look at the R-squared value. That's given up here. Now, R-squared, what is R-squared? R-squared measures the strength of the regression, and we can interpret it as follows. It's the percent of service level, the Y, that's explained by, the percent of variation in service level, the Y, that's explained by people hours, the X. In this case, we're going to be, in basically all cases, we're going to be looking for 70% to 80% to have a really good, or above, to have a really good regression. So this is not a very strong regression, 0.27, not very strong. We'll just make a note of that, and in fact, I wouldn't feel that confident making predictions from this model. I'd want to improve it first. But we're going to go ahead and do it just because we want to go through the motions. The third is to check the residuals. That helps us understand, are the assumptions of the model being met? Now, the assumptions, without going too deeply into it, are twofold. One is that the residuals are normal, approximately. And the second thing is that they are what's called IID, identical, essentially identically distributed, independent, identically distributed variables. Now what that amounts to is if we find anything weird in one of the pictures, we're going to look at, in 2 of the pictures, we're going to look at to see if it's more or less a normal curve, which it is. It's not bad at all. This is the third picture, and this is the one that we want to spend our time with. We spend about 5 seconds looking to see if we see any patterns. Now the 2 most prevalent patterns that we're going to see are this one right here. Whoops, let me make it a black pen. This one right here, which is called non-constant variance. So essentially what happens very often is that models will start to increase in their variation as x increases. We don't want that, and we'll show you how to deal with that in polynomial regression, but especially in transformations. The second pattern that we're going to look for, or that will often happen, is we'll get some sort of curve. That curve might look something like this, or whatever. You know, we'll get some sort of curve. That usually means we've chosen the wrong form to fit. I'll show you what that looks like in one of the examples I do near the end. Okay, but these residuals are totally fine, and so we're ready to move on. And that's the 3 steps. Now we're going to go ahead and do the prediction. So at this point, we can go down to where it says prediction and inverse prediction. We're more interested in prediction than inverse prediction. Let's walk before we run. Whoops. Just trying to expand that a little bit. And I'll also try and take some of the significant digits. I always hate how Excel gives me so many significant digits, like I needed 15 of them. All right. So here we are. Essentially what we're doing is we're plugging in for x, and then XLSTATS will crunch through this formula that it calculated, right? Service levels equal to 1.054 times people hours plus 62, and it will give me an answer. It will also give me a bound for what it thinks is the lower bound on that answer and the upper bound on that answer. So let's check it out. What if we put in 10 people hours? What would our service level be? We would predict it would be about 72, but it could be anywhere between 60 and 84. What if we put in 15 people hours? If we put in 15 people hours, the prediction says we would use 77, but it could be anywhere between 66 and 89. If you want to see the whole picture, you can click on confidence and prediction bands, and it'll give you a picture of the whole prediction area. See that there? Yeah. Okay. Let's go back. And that's it, folks. So again, just to recap, what we did was hello. Oh, okay. Well, I guess I'm going to have to write. What we did was we looked at regression analysis, and in that regression, we did 4 things. One was we built the model, and that was p-value, right? Second, we looked at the R-squared, which is the strength of the model. Remember, we're shooting for, say, 70% to 80%. That's the idea. Third thing was that we wanted to look at the residuals. And we're just looking for patterns there. And finally, we made predictions. We used the model. Okay, so that's the steps. All right, let's take a look at now a look at what happens. Now, since this is not a very good R-squared, it's not a very good model, what would we do? Well, what we can do, we'll find out, is use something called multiple regression. We can add in different X variables, more predictors, to make it better. And I just want to show you how that happens. Let's go to service and capacity. What would happen if we wanted to add in experience as well? In XLSTATS, that's the n-num function. Anything above 2 would be n numbers. And again, we have to arrange it so that we get the right things here. And let's go through the motions again. And this will show you that checking that p-value actually does have some value. You see, now that we fit in experience, what I'm also looking at here is I'm looking to see if experience also affects service level along with people hours. And there it is. There's the equation that XLSTATS built for me, which is kind of a good equation. You can see it has 2 terms in it. It has 1 term for experience and 1 term for people hours, plus the constant. And we can see that, indeed, the one for experience is more of a driver. There's the tiny p-value. And for people hours, it's just borderline. So if it were a little higher, we would even take it out of the model. Check out that R-squared, though. It went from 28% or 26% all the way to 75%. So much better and much tighter in terms of its prediction. So now, however, when we make predictions, we not only have to put in people hours, but we have to put in the average experience level of people as well. So if we had average experience of 3 years, people hours of 10, we would make a prediction. Again, I'm going to get rid of some of those decimal points because it's very annoying. There we go. Of a service level of 78, but the bounds would be from 71 to 85. You'll notice that that's a lot tighter than it was before. All right, if I put in, what if I had an average experience of 4? What would that mean then? And I put in 15 people hours. Well, that would tell me that my service level is 85, but it could be as low as 78 and as high as 92. So you see, it's a lot tighter now that we've added in that second term. And by the way, we can analyze those on tab 2, one by one, and we can actually see, look how tight that is for the experience. And let's check out people hours, a lot less tight. So in fact, it was experience that drove it more. Okay, let's do a couple of more examples. This is the example. I'd like to do the example of forms. Now we're just going to go back to simple one. I'd like to do the example of forms that's basically given on 42. This is part of your homework as well. What would happen in this case when we have a Six Sigma team that might be interested in how long does it take somebody to process a form, and they feel that it may have something to do with how many fields are on that form that somebody has to fill in. So let's go ahead and do that. To num. And again, we have to make sure that we have the X and the Y right. In this case, it's processing time, that's the Y. Fields, that's the X. Looks pretty good. We do have an outlier there that we probably would want to check out in real life. And maybe we even have a group of things right there that we might want to check out in real life. This is just an example, so we're going to move on.org. Correlation is 0.7, so I'm guessing that is pretty significant. Yep, you bet. It sure is. Let's build the regression model now. Here's my check for the slope. Got to keep it in. Here's my R-squared. It's 49, 50%. It's not too bad. But I'd like more if I could. And let's go ahead and now, check the residuals. I almost forgot about that. Don't see anything remarkable, although I do see somewhat of a fan shape, right? So we'll learn a little bit later that we can deal with that by a transformation, but we prefer not to if we don't have to. So in this case, since it's borderline, we will move on, and we will just go ahead and make our predictions. Let's see what it would take if we had 12 fields. What would we predict? Well, we predict that the lower processing time, or the processing time would be 39 seconds, with a lower bound of 12 and an upper bound of 66.8. How about if we had 23 fields, I'm sorry. We would expect it to take 79 seconds, 77.9 seconds, the lower bound of 48, upper bound of 107. So there we have it. There's an example where I think you could use this pretty quickly. You'd of course want to improve this, and we will go on and improve it when we look at indicator variables. There's a way to do that. There's actually an easy way to do that in XLSTATS, of course, and that is to, in this case, we've got form type. Maybe the type of form also affects it, and that would be, in this case, 2num1cat. And we'll have to choose the right thing here. Processing time, fields, and of course my form type. And you can see that it's fitting different models for each of the different types of forms. And it might be a little bit complex, but you can see that for each of the different forms it has a different equation that is fitting. All right, we'll cover that in a little bit later. Okay, let's do the last example that I wanted to cover today, and that's alligator. Okay, in this case, we have the length of an alligator and the weight of an alligator. Our job is to measure weights of alligators. Maybe we're a park ranger in Everglades National Park, and we're checking the health of the alligators. But I got to tell you, I don't want to get in the water and measure the weight. I'd rather just do it by how long they are. So let's see if we can predict one versus the other. Too numb. There's our scatter plot. There's an outlier or two. Let's just go ahead and do the regression. What do we say? First, we fit the model. Well, the model certainly looks like it's okay. I mean, like it needs to have that x term in there. That's a pretty small p-value. Second thing is r squared. R squared's pretty good. Third thing is the residuals. You didn't forget about the residuals, right? Need to check the residuals. These look okay. The normality assumption maybe is a little bit weird. That looks a little curved to me, and that looks a little skewed to me. But I'm willing to say okay. Oh, but I'm not willing to say okay to this. Check it. Hey, check it out. I've got my classic pattern there. In this case, I've got that curve, just like this. Let me get rid of all this so we can see just the curve. There we go. I've got that curve going on. Okay, certainly I've got a pattern in my residuals. So I got to fix that. That's so bad. I feel very uncomfortable making predictions with this one. Now, again, with only one variable, it's usually pretty easy to tell. And the way that you tell is by looking at that scatter plot, because when you do so, you'll see, oh my gosh, we really shouldn't be fitting a line. We should fit something else. We cover this in polynomial regression, which is a different lecture, but it's on extra tools, and then we have to select polynomial. And there it is. We can select many different degrees of the polynomial. There's our line. If we select something with a little curvature, we can fit it much better. Okay? All right. So that's it, folks. Remember, when you're doing a regression, don't just take the computer program's excuse me, word for it. Check it out. Look at the R squared, and definitely look at the residuals before you move on. Okay. Hope you enjoyed this one, and hope you found it helpful. We actually did do one or two of the homework problems, so hopefully that helped. Take care.